Hello, my name is Nicholas Holland. I attend the Dr. Gene Burton College and Career Academy. Today is February 27th, 2022, and today I'll present reverse engineering through flashlight redesign. This talk will focus on three major concepts. 1, our customer need. 2, functional modeling. And 3, our final proposed design. First, we created 9 interview questions as part of identifying our customer need. After being given the flashlight, me and my team created 9 unique interview questions to directly ask our customer to receive feedback. Through this feedback, in the customer statement section, would allow us to directly hear back from our customers on how they felt about the flashlight, also as answering the question to help identify their need. We also included an importance of need table or section of the table, 3 being critical, 2 being important, 1 being nice to have. This would allow us to rank the feedback from each other on how important the customer found it, so later on when we functionally model, it allows us to focus more on areas that the customer found more critical to be improved than one that the customer might think is already good enough. Next, we created a needs metrics table. This allowed us, from the previous 9 interview questions, to organize them into 8 customer needs. Then, in the next section of the table, labeled performance metric, we came up with ways to identify where the flashlight currently stands, almost as a benchmark. So that way, if we know how our flashlight currently performs, we can therefore functionally model and redesign a flashlight that can be statistically better. First, we did a crush test, and the data resides here. We did 6 trials using a force meter, putting the flashlight under it and increasing the force through a crank until the flashlight crushed. We did this 6 different times to take an average of how much pressure it takes to crush the flashlight and therefore how durable. Next, we did a crank test, as you can see here. It allowed us to identify how much force it takes to press on the flashlight in 2 different places, A being the farthest piece of the crank away from the flashlight, and B being closest near the flashlight body. We then did a light intensity test, taking the flashlight and using its crank feature to emit light at 4 different distances, 4 different times, to allow us to see how bright the flashlight is at different areas. We measured this in lux, and then we did a sound intensity test over, again, 4 distances, 4 different times, so that way we have a broad spectrum of data to allow us to analyze on how loud the flashlight is. We measured this test through decibels. Next, we came up with specifications for our new design. After all that testing, we decided what our new specifications must be for the flashlight. When we functionally model and redesign, we decided that our new flashlight must either be greater in some areas or less in some areas. These were all, again, based back to our customer needs and the feedback that we received from the interview questions. Our first part of functional modeling was creating a user flowchart. This allowed us to look at all the different actions a customer or user of our product might take to allow us to specifically target them for functional modeling, so that way we redesign something that the customer will notice and appreciate over something that they think is already good enough. Next, we created a action function table. This allowed us to take all those actions we identified in the customer use flowchart, which we created last, and turn them into functions. These functions then are a piece of the flashlight. They're a step further of identifying where in our flashlight we can redesign. We're more than knowing what the customer is doing with the flashlight, we know what the flashlight is doing, and then we were able to ask 2 specific questions on how we can redesign it. This, again, continues to allow us to specifically target areas for redesign, but also generate lots of ideas. Next, we created a view chart. This allowed us to take all of our customer needs so far and rank them along other designs. We started with a base design of an existing crank and upgrading it to a new crank. That was our base design. We gave it all 0s. Then in the next 3 designs, a longer gear ratio, a build with higher quality and better construction materials, and then finally a more compact version of the flashlight. We rated them on all the criteria with a plus if it improved on our base design, a minus if it did worse than our base design, and a 0 or a nullifying mark if it did not improve or worsen the performance of the existing design. Then we took all the positives and all the negatives of each design and added them together to get a net total. This net total told us if the designs were more net positive or net negative, and it allowed us to scientifically pick the most net positive result through customer need and research data, and allowed us to make an informed decision on which design would be best, which ended up being the solid, high quality material build with a new, reinforced, more structural build. We then created a detailed C-sketch of the idea we envisioned. This was our last step before progressing to creating our final design for the manufacturer, because it allowed us to realize if we can actually create this, that it's not just a vision, but it's something we can actually sketch and we can actually create. This is the first image with dimensions of our final design. It has the higher quality, thicker plastics. We used a significantly more high quality ABS plastic. We also made the plastic solid and opaque. Here, an inside view of the flashlight, you can see that the plastic is twice as thick as the original flashlight, and that we also added structural ribs to it to reinforce the flashlight. Then, after designing a new flashlight, we created another specifications table, so when we present it to our manufacturer, we are allowed to say that this new design is better on these metrics by this much, by this qualitative data, so that way there's an actual reason for us presenting this design, and it's not because we found it to be the most effective. We have qualitative data to back it up. In conclusion, reverse engineering was a very successful way to improve this flashlight. We learned that if you can start with a product and find your customer need, once you have a customer need, you can create a better flashlight. Because if you can directly impact what the customer wants, you're bound for success because your design is targeted. If there are any questions, please contact me. If not, thank you for your time.